All
right, there we are.
Okay, great. So welcome everybody, and thanks for coming to our rather informal virtual open house hosted by myself. I'm Professor Reiner and Professor Woodworth. And what we're seeing here is a couple of pictures of the VCU campus along with a microscope objective with a laser in our physics department. And what we're going to do here is just give you a broad overview of why one would want to major in physics and what we can do for you if you're interested in physics, and what are the types of things you can study in the VCU physics department. So of course, I always start with this slide for everybody, but if you've taken a physics class or are in the middle of physics, you probably don't need this slide. But what is physics? It's a lot of different things. It's trying to understand the physical world around us. And so we ask questions like, how do things move? Why do things fall? How does stuff heat up? What's going on with electricity, circuits, lasers, atoms? All these questions, all these issues can fall under the umbrella of physics. So clearly physics is a very broad topic and can be very interesting to study, but I think there's some misconceptions about physics, a couple of different things about that might be keeping people away from studying physics. So I've talked to a lot of students in the past, and I've kind of seen three major comments or questions come up when it comes to talking about physics. And one of them is that people tend to think that you have to be a genius to study physics. So I've got my picture of Sheldon Cooper, and I love that show, Big Bang Theory. So with all due respect to Sheldon Cooper, no, you do not have to be a genius to study physics, okay? It's just not true. Physics is more accessible than people realize, and there are many ways which one can learn and apply physics concepts. So that's the first important thing I want to get across, is that it's not just limited to the very few geniuses in the world. Physics is something that could be and should be studied by a broader swath of the population. Another concern I hear from people is that, well, physics just has too much math, and I've got my picture of this, the stock image of somebody who's upset with some math, but this is not necessarily true. Yes, some physics does use quite a bit of math. That's absolutely true. But the fact is, that's not true for all physicists. In fact, most working physicists, myself included, we don't really work on what I call Einstein-like problems with very high-powered math that require deep understanding of theoretical concepts. A lot of physicists are very successful and don't spend a whole lot of time dealing with math at all. I mean, you have to know some math to get through some of the concepts, but it really shouldn't be something that keeps you from trying to study and go into to studying physics. And the last comment I get, it actually tends to come more from the parent side than the student side, but I get a lot of this. They say it is, what can you do with a physics degree? Or the more negative form, I guess, is you can't do anything with a physics degree. So unfortunately, we have the picture here, another stock picture of the poor person who maybe got a physics degree and now they can't find a job. And I really want to drive home the point that that is not true at all. There are just many career paths for people that study physics in college. And that's mainly what our talk tonight is about. I just want to introduce you to some of those ideas. And so hopefully I'll be able to convince you of that fact here with these slides. So here's my, the pie chart I always start with here is, what can you do with a physics degree? And so usually people think you can do one of, two things. You can either go be a physics teacher, or you can just go maybe to graduate school and get a PhD. And so as you can see in this pie chart here, becoming a physics teacher is a reasonable size slice, but it is clearly not the entire slice at all. It's not the whole pie, right? It's about 14% of people who get a bachelor's degree in physics go on to teach, which is great. We need good physics teachers, but that doesn't mean everyone does that. And so another group of people will go off to graduate school and try to get a doctorate or master's degree in physics, and that's this slice here. But you can see that all the rest of this stuff here is what other physics majors do when they graduate from college with a physics degree. So some might go into non-physics education, quite a few go into engineering, and that's a very popular track for our physics majors as well. We have a lot of double majors doing partial engineering, partial physics. You can see a lot of computer hardware and software work. A surprising one here, business. 8% of physics graduates end up going up into some kind of a business-related field. And then you can see some other areas here. And this one I wanted to point out is medicine. So 3% of the people will actually go off into the medical fields. And so that's something to bear in mind for our department in particular. This here is just a little list I put together of Virginia employers who recently hired new physics bachelor recipients. And this is just a huge list. It's a lot of people up in the DC area, up in the Beltway area, down in Richmond, along the shore there. You can see all these different companies and labs and places that are very interested in hiring physicists. And so, what can, that kind of shows you that physics, is of interest to people. There's a market for it, but what exactly can we do in the VCU physics department? What can we offer you to make that come true? And here we have our obligatory picture of the department. You can see there's a picture of me. This is pre-COVID. I'm wearing a mask for an experiment I'm doing in the forensics department. So that's what that's all about. I'm looking for Pat. Actually, there's Dr. Woodworth. There's Pat sitting there helping me set up some table for some kind of a physics related activity. And so anyways, you can see that, there's a lot of activity, a lot of buzz going on in our department, but I wanted to say that, most physics departments will specialize in certain subtopics. So you pick a university and you might say, oh, I want to go study physics or work on physics. What you'll find is that, usually a department will say, well, we specialize in one area or two or three areas of physics. So maybe somebody does like astrophysics or somebody does solid state physics, something like that. So what we at VCU do is we focus on two main areas. One of them is nanoscience and the other is biomedical applications. And so I'm going to talk a little bit about the nanoscience side, and then I'm going to let Pat talk about the biomedical application side here. So just to get the ball rolling here, what do I mean by nanoscience? Well, nano, of course, is that prefix 1/billionth, right? It's a very small unit, but that's the length scale at which things really start to get interesting for a lot of different materials. And so what role does VCU have in nanoscience? And the easiest way I can convey to you how VCU is connected to the nano world is through our Nanomaterials Characterization Core Facility, or in short for the NCC. And what you're looking at is a picture from the outside here, and on the inside is about $12 million worth of equipment. And you can see here, I've bulleted off most of the pieces we have, not everything, but basically what you have is a collection of devices and machinery that if you come into our program, you have the opportunity to learn how to work with most, if not all, of these devices. And if you can put those skills on a resume by the time you graduate with a physics degree, you become extremely employable and your career prospects really take off. And so what you're looking at here are a lot of tools that are able to probe things at the nano scale. And of course, this is where a lot of areas of technology and science are very much focused these days. So that gives you an idea of the resources we have. And this here is just talking about how our program works to provide marketable skills and a path towards a rewarding STEM career. So in addition to providing access to this high-tech equipment, our physics department consists of a number of highly active physics researchers, myself included, who frequently work with undergraduate students. So we're kind of a smaller department, but that has advantages and disadvantages. And one of the big advantages is that we're more able to work one-on-one with our undergraduate students. Sometimes you go to a bigger university, a larger program, and you end up getting kind of a little bit lost in the shuffle perhaps, and you end up working with graduate students and postdoctoral fellows and not spending a whole lot of time with the PI themselves. Where in our program, we're a little bit small, we can give you that kind of that more one-on-one interaction and expose undergraduates to these research opportunities. And this here is just a little, I kind of cherry picked a couple of emails. We've received these emails in the past few weeks, actually, from some of our physics alumni, but we get messages from our previous students all the time who've gone on to work at some of these high-tech companies. And, we'll get these unsolicited emails. And I just want to show you a couple of them here. We've got this person here working and, they were asking us, do you have any students who are looking for a job? We are hiring like mad. P.S. I got a management position in June, so they're on their way. They're doing very well in the career path. This person here is saying, hey, do you have any good kids looking for a tech job? We have an opening in Rolls-Royce. So there's a company that you might not immediately associate with a physics degree, but there you go. They're, of course, interested in hiring physicists. And this one here, I like. This is from a company here. We are in the process of hiring a lot of new people. And I bolded this. Our company has a heavy bias towards physics majors with applications. So he goes on to talk about my class, which is a blatant plug on my part. But the point I'm trying to make here is this is just a little bit of a sampling of the different companies that some of our recent graduates have gone off to work for. So it sort of shows you that we have these inroads with industry. We take very seriously our connection to industry, and we're always communicating with them and making sure that we're designing our curriculum to make sure that it fits nicely with the interests that they have. So we're very much on top of that and making sure that that we're on the cutting edge of what industry is looking for. So as a little show here, I'm just putting this up here. As I usually tell my students, since this is being recorded, I won't spend a whole lot of time. You can go back and watch this later, but you can see the list of requirements for the physics degree. And these are the core courses that do not include things like general education electives. So you might have to take some liberal arts courses or whatnot, but I haven't listed those. These are the core courses for physics. And one thing I wanted to point out here is that we currently have a total of 30 required credits. Now, to get a degree from VCU in most state schools, you need 120 total credits. So as you can see, that's only a quarter of the total credits you need. And so that's actually, I see that as a positive because it really opens the door to taking a lot of interesting electives, courses that can help you develop and work towards building that resume and helping you launch that career that you're trying to go for after you graduate with us. So this is just sort of showing the typical plan of study. You have the introductory courses, you have the intermediate courses, and then the courses that get a little bit more advanced up in here, and then the senior lab and the capstone, and then you wrap everything up and finish up. Now we have, in addition to the physics degree, we have a nanoscience concentration, which is basically a physics degree with an emphasis on nanoscience. Now that term nanoscience basically means that we're going to do everything we can to make sure you get connected into those opportunities I was talking about before at the NCC and those research opportunities. And so as part of that, what we've done is picked out a couple of courses that we think are pretty critical for understanding those skills and ideas. And then on top of that, we ask you to take a couple of different electives. Now I've listed a few here. This is by no means the only courses you can take. You talk to the advisors in our program, and you can go ahead and start picking other courses that you feel might be a better fit for the things that you'd like to do after you graduate. And the only other thing I'd like to add here is that our physics degree has a low number of credits, and this is good because this allows us to easily couple to a lot of the engineering programs at VCU. So we have I'd say about a third of our majors are actually double majors between both physics and some subfield of engineering. And so I personally think double majoring with engineering and physics is a great thing to do because it allows you to get that the skills you learn from engineering, but also to kind of figure out a way to get the foundational knowledge that you can pick up from physics. So that takes us to the part of the talk there where Pat, I think, will not take over, which he's going to talk a little bit more about his area of expertise, which is our new pre-medical concentration. So Pat, if you want to go ahead,
Sure.
I can just adjust the slides for you if you want.
All right, yeah. I'll give you like a thumbs up or something when I'm ready to turn.
Yeah, sure. Yep.
So yes, I'm going to talk about the pre-med concentration, which is a new track that really just started, I think, last fall. So we're only 1 year into it. When I say pre-med concentration, you might immediately think that question on the top there: what does physics have to do with medicine? A lot of people don't realize that physics is involved. Well, I should say they should realize, right? But physics is involved in everywhere, right? Every aspect of the world, physics is there. So when we think about medicine, a lot of people think about the doctor in a hospital or your even just your general practitioner that you go to. We don't think about someone what was behind them to get them to that point, and again trying to connect that to physics. So on the slide you can see I have imaging on the right, or on the left, excuse me. MRIs, X-rays, these are scans. These are all concepts in physics that we talk about, that we study. In the middle, right? Sensors, EKG, wearable sensors, nanosensors, right? There's nano, or this ties right into our nano concentration. And on the right, we've got proton therapy, but think about radiation therapy. You may or may not be familiar with different types of cancer treatments. But this is all the underlying concepts for all of these technologies, or I guess all technologies and treatments fall in physics, right? So it's all based in physics. And the ones that I'm highlighting here are the ones that the doctors who are in with patients, patient-centered people, and again, showing that behind it is physics. Go to the next. There's also the research side to it. Physics does have a research-centered medical connections with physics include single cell and single molecule analysis. That's actually in part what Dr. Reiner does on the bottom there, and we have other researcher who works with imaging of cancer cells. So this is, I guess, behind the scenes, the people that may or may not be as, when we think about medicine and pre-med, we might not think about the researchers behind it. In the middle, we have people here that are doing materials processing. For example, 3D printing. We have a new biophysics professor who's working with a 3D printer. And of course, on the right there, we see physics of cancer. Right? Cancer is a big area of research. Especially if you're familiar with VCU and if you're local, you know that we have a connection with the medical college, which is down the road from our department, but it's close. There's a lot of overlap between our department and the medical campus. Lots of collaborations going on there. So that's why we look at physics and or how physics really applies to medicine. If you've never thought about a pre-med track and you don't know what it is, those first 3 bullet points kind of highlight that. A pre-med concentration it's a course of study that's intended to prepare students for medical school. It should prepare students to take the medical college admissions test or the MCAT test. You may have heard of the MCAT test at some point. That's actually one of the courses that I teach is an MCAT prep course. And the third one, a student can be any major and still be pre-med. This is something that a lot of people don't know. A lot of people think that to be a pre-med concentration or pre-med, you need to major in biology or something associated with biology. But in actuality, it doesn't matter what your major is. What matters is those common prerequisite courses, those science courses that are required or is even recommended by medical schools. So the medical school is going to look at those other courses that you're taking, not necessarily looking at your major. In fact, I think I was just speaking with a student not too long ago whose major, I think, was English, minored in women's studies, but was in pre-med track. So things that I don't know how they go together, but he's making it work. So that's an example that you can major in anything you want as long as you're taking those extra courses that can prepare you for a medical school, right? And that's really what a pre-med track is. It's those extra courses. So in the VCU Physics department, what we can offer, our curriculum prepares students for a health sciences career. And we're using physics-based technologies, the technologies that Dr. Reiner was talking about that I showed on the previous slides. Right? These are what our curriculum is set to do. Students from this program who apply to medical school will have a distinctively rigorous preparation. And I'm highlighting distinctively because that's where we stand out. And that will come up in just a second when I show you some data. The curriculum also prepares students for other graduate medical physics or even biomedical engineering and really just any MD or PhD programs. So having this pre-med concentration and you decide not to go into the medical school, it's very easy to switch gears and go back into just a graduate medical physics program or something else. So the plan of study, like again, Dr. Reiner was showing for the nanoscience concentration, you can see here, we've got our major requirements on the left. Those are the core 30 that we're talking about. On the bottom, we've developed some new courses specifically for physics majors who are in the pre-med concentration. So the Physics 317 course is one that I'm teaching, preparing for the MCAT. One thing that people don't realize is the MCAT is as much about knowledge as it is your ability to sit in a chair for 6 hours or 7 hours. So there's a lot of things that you have to go through to prepare for that test. We have biomedical physics classes that will be offered. Biomedical analytics or some kind of data science will be offered for specifically for physics pre-med concentration people. And on the right, you can see the ancillary requirements. So at the top, I do have the 120 credits, like was mentioned before, with 37 in physics and physics-related electives. That's the ones that are on the left. And then the 48 to 56 in ancillary requirements. So this is your pre-med requirements. In addition to the new ones that we have, you can see on there, there's biology, right? Got lots of biology. So you have to take biology, chemistry. There's inorganic or organic chemistry, general chemistry. There should be at some point, well, another elective you could take would be a biochemistry course. Those are all important subjects that fall into the medical side. And of course, some math classes at the bottom there. So how can physics train students for a medical career? So one thing is that physical sciences have top medical school acceptance rates by major. So they are at the top for being accepted into medical school. And I've got in the parentheses there around 50% acceptance rate for physical science compared to 40% for biological science. Okay, so again, it's 10% more higher acceptance rate than biological sciences. And physics students perform very well on the MCAT test. That's going to come up in just a second again. And again, VCU's physics department offers an unmatched mix of customized biomedical research opportunities and a one-to-one faculty accessibility. As Dr. Reiner was saying, we're a small department. Many of you who come to VCU will have the ability to, or the opportunity to work one-on-one with a faculty advisor in the areas of some form of biophysics, biomedical research. Our connection with the medical college, and more specifically the Massey Cancer Center, which I've got coming up here in just a second, allows us more opportunities to get involved in research, which is, again, as I'm saying here, an unmatched mix of the customizable. It's very customizable for what you're looking for. So as we said, physics majors do very well on the MCAT. All right, so there's a list of the MCAT scores, average MCAT scores, and actually, if you advance one slide, I highlighted the physics part. Right, physics are on top. Right? This is you can see biophysics has an average score of about 512.9. Physics as a major is 510.2. As the MCAT score, again, if you're not familiar with it, you aim for a 510. I mean, that's good, and that's actually very difficult to get. The few physics majors that, again, because this is a new department or new program, the few physics majors that have gone through it score, I won't say easily, but they get into those 510, 5.8, maybe on their first try or their couple practice exams right away. Compared to biology at the bottom, which has an average score of 505.9. And a lot of what you do when you're preparing for the MCAT is trying to get those extra 5 points or even 10 points. That makes a big difference when you go to medical colleges. So again, just showing that biophysics, physics is higher, typically do better on the MCAT scores than the biology or other biomedical science and pre-medical degrees. The other thing is, if you look at the number of applicants, right? For biophysics, there were 84 applicants. Right? For physics, there was 186 applicants compared to all of biology, which has 62,443 applicants. So that's quite a big difference in numbers. So that we've got a small group of people who are physics majors who are applying for medical colleges. What's that? The total is 270, right? 270 compared to 62,000. That's like 0.5% of that, right? So it's a very, very small, but acceptance rates are higher for those biophysics. So again, that distinctively rigorous curriculum that physics offers makes you stand out. So as I was mentioning before, we have a connection with the Massey Cancer Center. We have many collaborations on the left and the right. You can see, or I'm sorry, on the left, you can see just different areas of research, different places that are all involved with the pre-medical track. And as I said too, VCU Physics already has a considerable overlap with the Massey Cancer Center, which is right in downtown Richmond. And you might not know this, but the Massey Cancer Center is one of only 2 centers in Virginia and one of 71 centers across the country with a National Cancer Institute designation. What that means is that they are, again, one of 2 institutes in Virginia that are acknowledged and acknowledged to do cancer research, right? So it's all based on cancer research. So at the medical school or at the medical college, you have the patient-centered people working along with patients, people who come in to get treatment. And you also have the heavy research side. So you do get that cutting edge kind of what's new, what's going on with any kind of, I guess, medical or cancer research.
Okay, so thank you, Pat. Yeah, so that, and just to add one more point onto that is that, again, VCU Physics, we're a smaller department, but we've tried our best to take advantage of the opportunities around us. And so, as I said, there's that Nanocharacterization Center, millions of dollars going into that. And we're also in close proximity to these medical collaborators as well. And so with that in mind, that sort of has motivated our department to sort of focus in on the nano side of things and on the bio-related side of things, the medical side of things. So I think that's been kind of our driving mission over the past, I don't know, 10 or so years, at least I've been in the program here. And I just wanted to leave with one more thought here before we close this off, which is, we've heard a lot about, job opportunities, career opportunities, how to make something of yourself with your, these different choices of things you want to study. But of course, when it comes to physicists, there are some of us that are just interested in studying physics for the sake of learning about physics. And what I wanted to say is that that's great too. Okay, what I've got a picture of here is that we've got some nice pictures, some high-powered concepts. Here we've got something that looks like quantum entanglement. This is a black hole. This is a picture from CERN. This is a picture from the LIGO detector. So you can see all these great, esoteric concepts in physics. And what I wanted to say is that we also offer a number of high-level courses that focus on these topics: so relativity, quantum mechanics, particle physics, astrophysics, etc. So with these courses, you can obtain a deeper understanding of the physical world around you. And this can help you further your education and perhaps allow you to move on into graduate school and beyond. So we've got a nice picture here to close up of Sheldon Cooper smiling at the idea that, of course, we're not just about doing applied stuff in the real world. We, of course, are looking at the big picture as well. And so we provide those opportunities also. So with that in mind, we're going to close off the talk here. And I'm thanking everyone for stopping by and listening here. We hope to hear from you soon. Just a couple of important dates coming up for this fall. The VCU open house, is going to be 2 in-person VCU open houses, October 8th and 29th. And on this one here, the 8th, it's my understanding that we're going to do little pre-talks from all of the major departments at the Siegel Center. So if you want to come see me talk in front of a big crowd and see what that looks like, I'll give a little 2-minute presentation about what the physics department's all about on the 8th. You're welcome to come check that out. But if you prefer to stick with the virtual stuff, we also have another virtual open house VCU-wide on Wednesday, October 12th. One other point here, the VCU application deadline, just to put that on your calendar, January 15th. And of course, I leave this with just saying, feel free to contact us with any questions you might have. This is my name and my email address. And this is Professor Woodworth's name and email address. So you can kind of send us your messages if you so choose. So Pat, if you could go ahead and